In this video, we will compute the area of a region in polar coordinates. So we're asked to compute the area of the region which is inside of a cardioid and inside of a circle. So let's try to draw it first. So the cardioid, r equals 1 plus cosine theta, looks something like this. And the circle, r equals 3/2, looks something like this. And so we're computing this area, the region that's inside the circle and inside the cardioid. Now we're going to have to split this up into 2 or 3 pieces, depending on how you look at it. Because if you think about it, look where the two intersect. The circle and the cardioid intersect at these 2 points. And if I draw a line from the origin to these points, you'll see that this region that I'm coloring blue, the outside of this region is the circle. But for this red region, which is everything else, the outside of the red region is the cardioid. And so the integrals will be different for the two. So let's call this blue region D1. And let's call the red regions D2 and D3. Then the area of the whole thing will be the sum of the areas of the 3 pieces. And remember, to compute the area of a region, you just integrate 1. And so we'll just integrate over all 3 regions. And notice by symmetry that the 2 red regions are actually the same. D2 and D3 are just reflections of each other. So these 2 integrals will actually give the same answer. So really we can just compute the area of D2 and double it. So this is how we'll compute the area. So let's erase this to save room and rewrite this at the top. So we're going to compute the area of D1 and D2, and then our final answer will be to combine them like this. Okay. So first we have to figure out how to describe D1 and D2 by inequalities so that we can write the bounds on these integrals. So in order to do so, we need to figure out where these blue points in the picture are, where the 2 curves intersect. And this isn't too hard to do. So we have r is 1 plus cosine theta and r is 3/2. So they're both solved for r, so we can set them equal to each other. So 1 plus cosine theta equals 3/2. Subtract 1 from both sides, we get cosine theta is 1/2. And here we know that there's just 2 angles for which that's true, plus and minus pi over 3. So these 2 blue radial lines that I've drawn in the picture are the lines theta equals pi over 3 and theta equals minus pi over 3. So let's first compute the area of D1. So we'll convert this integral to polar coordinates. So theta goes from minus pi over 3 to pi over 3. And r goes from 0 to, and we said that the upper bound here, the outer edge of this region is the circle. So that's r equals 3 halves. And dA becomes r dr d theta. So if we first do the r integral, we get 1/2 r squared. So 3/2 squared minus 0 squared is 9/4. So we get 9/8 times the integral of d theta. And the integral of d theta is just theta. And the width of this interval is 2 pi over 3. So we get 9/8 times 2 pi over 3, which is 3 pi over 4. So this is the area of the blue region D1, is 3 pi over 4. Let's circle it in blue since we colored that region blue in the picture. Okay, now we have to find the area of the red regions. So now let's compute the area of D2. So we divided the red region into two pieces, D2 and D3. So if we did the entire red region as one piece instead of two, theta would go from pi over 3 around counterclockwise to here, which negative pi over 3 is the same thing as 5 pi over 3. But we don't want to do the whole thing, we're cutting it in half, so we're only going halfway. And the halfway point here is when theta equals pi. So really, we're just going from theta equals pi over 3 to theta equals pi. You can see why that's the halfway point if you look back at the original equation for the cardioid. If you plug in theta equals pi, cosine of pi is -1, and r is going to be 0 there. And the halfway point is exactly where the cardioid comes back to the origin, so r should be 0. Okay, and r goes from 0 from the origin out to the cardioid, so 1 plus cosine theta. And again, dA becomes r dr d theta. So same thing as the first one. We first integrate r. We get 1/2 r squared. So we get 1 plus cosine theta squared. And let's actually square it out. So we get 1 plus 2 cosine theta plus cosine squared theta. So let's split this into 3 integrals. The first integral is just 1. Second integral is 2 cosine theta. And the third is cosine squared. But let's remember, the way to integrate cosine squared is to use the trig identity, that cosine squared is equal to 1/2 1 plus cosine of 2 theta. Okay. First one's easy. It's pi minus pi over 3. It's 2 pi over 3. The integral of cosine is sine. And then, again, the integral of 1 is just theta. So it's pi minus pi over 3, which is 2 pi over 3. And the integral of cosine 2 theta is 1/2 sine of 2 theta, which we have to evaluate from pi over 3 to pi. So sine of pi is 0. Sine of pi over 3 is square root of 3 over 2. But we have to subtract it, so 0 minus square root of 3 over 2 times 2 is minus square root of 3. Plus, let's distribute the 1/2. So we get pi over 3 plus 1/4 times, and here we have to plug this in. Sine of 2 pi is 0 minus sine of 2 pi over 3 is square root of 3 over 2. So that's minus square root of 3 over 2. So let's just combine it and write that as square root of 3 over 8. And now finally let's just multiply everything out. So we have pi over 3 minus square root of 3 over 2 plus pi over 6 minus square root of 3 over 16. And we can combine some stuff together. Pi over 3 plus pi over 6 is pi over 2. And if we add the square root of 3 terms, that's minus 9/16 times square root of 3. Okay, so back to the beginning. Well, first, we've computed the area of D2. It's this, let's circle it in red. And now back to the beginning, remember what we're doing. We're adding the area of D1 plus 2 times the area of D2. So, our area of D1 was 3 pi over 4 plus 2 times, and the area of D2 that we just computed was this. So, all in all, if we distribute the 2, get plus pi minus 9/8 square root of 3, and just combine the pi terms and we're done. So we have 7/4 pi minus 9/8 times the square root of 3. And that is our final answer.